When we're trying to find all solutions of a trig equation? Well, I graphed for this is number 13 out of 6.4, and I graphed on Desmo, I graphed this side of the equation, and I'm trying to find when is this equation equal to 1, and so here's the sine graph, here's the equation y equals 1, and we see where I'm just showing you 4 of the solutions, and as you can see there's another one here, and we could keep going and find more. So how can we come up with an expression? How can we come up with a way to express all those different solutions is what we're trying to deal with. So for this question number 13, the first thing you want to do is we want to get the sine by itself. So since 2 sine 3 theta equals 1, I'm going to divide both sides by 2. So that gives me the sine of 3 theta equals 1/2. Now, that 3 theta seems problematic, so I'm going to pretend it's not there for a minute doing this little substitution. Okay, so really what I'm looking at right now, it's the sine. The sine of some angle equals 1/2. So mathematically what we're doing is we're taking the arc sine of both sides of this equation, and this is telling me what angle has a sine of 1/2. Well, if you think about your 30, 60 right triangles, right? That's 1, that's 2, that's the square root of 3. Well, this 30-degree angle has a sine that's equal to 1 over 2. So we know the angle in degrees is 30 degrees. We like to do our work in radians, so that's pi over 6. So I know that u equals pi over 6. Okay, but we did do that little substitution earlier, so we need to do a little work here. Move that up. Move that up. So I know that 3 times theta equals pi over 6. Now, the other thing we're going to worry about is when, because there was a lot of answers, sine is equal to 1/2 up here in this first quadrant. So remember, that's 1, that's 2. But sine's also equal to 1/2 over here in quadrant 2. That's 1 and that's 2. So if this angle is 30 degrees or pi over 6, that angle, that reference angle, is also 30 degrees or pi over 6, which makes this one, and I'm just going to be working in radians since that's where we want to go. That's pi minus pi over 6 will be this angle here, right? So that's 5 pi over 6. So I know that 3 times theta also has to equal 5 pi over 6. Okay, and then before we even think about the 3 theta, I know in order to get back to this angle here, I got to go all the way around a full rotation. So isn't that 2 pi? And if we're going to go around more than once, we'll stick a k. And the same idea with this other side. We're just going to add 2 pi k. That way, every time we go around the circle, or every time we repeat and hit that graph, that's a full cycle. But this pi, the 3 pi or 3 radians, that changes the period of this graph. So in order to account for that, we're just going to divide by 3, or maybe it'll be easier to think about this. I'm going to multiply by 1/3. So if I multiply both sides of this equation by 1/3, and both sides of this equation by 1/3, that's going to give me pi over 18 plus 2 pi over 3, which works out to be the period. And that's where we're getting that k. And same deal here. So we're going to get 5 pi over 18 plus 2 pi over 3 times k. And that is the two answers. And if I were to bring back that photograph of the graph, see is here's the pi over 18 answer, and if we add 2 pi over 3, right? If we take pi over 18, yeah, right, so I write 2. 2 pi over 18 plus 2 pi over 3, well, I'd have to get common denominators. So that would be 6, so that's going to be what, 12 pi over 18? Well, 1 pi over 18 plus 12 pi over 18 is 13 pi over 18. So that's the next time it goes around. And then we can do that same math here to get that point, or we could subtract 2 pi over 3 to get back to this point. So that's how you can come up with an expression to talk about all solutions. Hope that helps.